All right, guys, I'm going to try this video again. I've messed this up a couple of times already, but we're going to see what we come up with, okay? So, I'm just trying to find all my things here. Okay, so we're going to look at Gay-Lussac's law, combined gas law, and Avogadro's law. Okay, so hopefully after you've watched this video, you'll be able to do these things, explain the effects of gas properties on using Gay-Lussac's law, Avogadro's, and combined, and calculate using solving algebraically to find the different variables. All right, Joseph Gay-Lussac discovered the relationship between temperature and pressure. And basically what he found was for a given volume of a gas, as the temperature of an enclosed gas increases, the pressure of the gas is directly proportional. Okay, so here is the formula. P1 over T1 equals P2 over T2. Pressures have to be the same regardless. If I start with PSI, I got to end with PSI if I need PSI. If I have PSI and ATMs, I'm probably going to go to ATMs because they're a little bit easier. Everything must match, and your temperatures always are in kelvins. All right, so here is a formula, or an example. Your gas has a pressure of 1.3 kilopascals at 25 degrees Celsius. What will be the pressure of the temperature reaches 928 degrees Celsius? Well, first thing I like to do is write down all my variables, P1, T1, P2, T2, and then I start plugging in all my stuff. If you notice, I already converted the pressure and the temperature. So my pressure and my temperature are already converted right here. 25 degrees Celsius is now 298. I no longer am going to use this. I'm going to use 298. 928 is now converted to 1,201. And here is how I set this up. Okay, what I like to do is and I'm trying to find my pointer because my thing switched again on me. I like my highlighter. Okay, what I like to do is cross multiply. Take these two things and multiply them, and then I will take this here and cross multiply. Now, what it ends up being is that whatever I get for 103 times 1,201, I divide by 298, okay? And I get 420 kilopascals. Now, again, I'm ending with two significant figures because 25 degrees Celsius was my two significant figures I started with. Yes, 103 has 3, and this has 4, but we're going with the lowest one that we start with in the original problem, okay? All right, now I'm going to take, and hopefully this will work, but I'm going to talk about Avogadro's law. Now, earlier this did not work very well for me, but we're going to see if it works this time. Okay, I'm going to switch this over, and I'm going to have you copy this down in on your paper somewhere. Okay, it's Avogadro's law, and it says V1 N1 equals V2 N2. I can't see. Okay, and then I want you to write pause the video and copy this down. I can hold 6 grams of hydrogen gas at a volume of 1.5 liters. What is the new volume in milliliters if the moles increase to 12.3? Okay. All right, go ahead and take a minute, pause the video, write that down. Okay. What I did, hopefully you guys can see what I did here. I wrote all my variables down. I'm on the wrong side. Everything's backwards for me. I wrote all my variables down right here. Okay. You notice that I have grams. Sorry. So I had to convert right here. Right there. I had to convert 6 grams by doing my railroad tracks and taking my molar mass of hydrogen. And I went out 4 digits. You don't have to, but I did, just because I like to go out 4 digits when I do moles. I then plugged everything into my formula. I cross-multiplied, and when I did that, I got 18.45 equals 2.976. I divided by the one with the X, and I got 6.2 liters. Well, I can't have liters because my question asked for milliliters, so I multiplied times 1,000 because 1,000 milliliters equals 1 liter, and I got 6,200 milliliters. That's how I solved for Avogadro's number, okay? Avogadro's equation, okay? Let's see if this works. Okay, hopefully this worked, but I also want you to look in the corner, and I have combined gas law, the one that we have in class, because this is missing the N2, N1 and N2. So make sure you have that on your you have it in your foldable, but make sure you have it on these notes. The combined gas law is a simple equation or single expression that combines Boyle's, Charles, Avogadro's, and Gay-Lussac's law. Okay, so this law describes the relationship between temperature, pressure, moles, and volume of a gas. It always also allows you to do calculations where only certain things are present, and ignore that last amount of gas because that's the moles. Okay, so we can change the amount of gas and it changes everything. Okay, so again, put an N in there like the one I have in the corner over here. Make sure you have that one. Hopefully you guys can see it. P1 V1 N1 N2 P1 V1 over N1 T1 equals P2 V2 over N2 T2. Okay. All right, so some helpful hints here. You're able to get what law you need by covering the variable that is not mentioned in the problem. So if I don't have moles, I can take moles out. If I don't have moles, or I don't have something else, I can just have only one law. So there's no need to memorize 4 individual laws, just know combined gas law. So if we don't have any moles, we're keeping the amount constant, and we don't have a temperature, then we're going to be using Boyle's law. Okay, P1 V1 equals P2 V2. If we're looking for no mention of, we're keeping the moles the same, and we don't have pressure, now we're looking at Charles's law. Gay-Lussac's law, we don't have volume. Okay, if we had Avogadro's, we would just have volume and moles. Okay, so if you're looking at this problem here, a gas occupies 3.78 liters at 529 millimeters of mercury and 17.2 degrees Celsius. What pressure would the volume be if it went to this many liters at this much temperature? Again, write down your variables, P1, V1, T1, P2, V2, T2. I would even include an N1 and an N2 in here. Cross it out if you don't have it. We don't have N1 and N2. Cross it out. What are we looking for? Well, we're looking for the pressure. Okay, so we do have to make sure that our volumes are the same. Well, if I notice in here, volume is the same. I have liters and liters, so I'm good here. I still am going to change my temperatures, just like I did in the other laws. So I'm going to, you notice I changed all my temperatures. Okay, so here's my formula. I don't have, my moles are going to be the same, so I'm going to keep everything exactly the same on that part. All right, I'm going to plug in all my values. And I lost my little pen again. Okay, so we're going to just do this. I'll draw. Okay, so I'm going to take and multiply those 3 things, and then I'm going to multiply these 2. I'm going to divide. Let me see if I can change colors. Okay, work with me. Okay, whatever I get here, I'm going to divide by whatever I get here. Okay, so, all right, I messed up the video somehow here, so I'm not sure what's going on, but go ahead and if you want to find the answer to this and write it down. I have forgotten what it is, but actually, let me do it real quick. Let me see what it is. Let me pause this. The answer is 467. 3 significant figures, 467. Okay, sorry about that. I'm going to cut this video a little short. I look kind of goofy up in the corner. Apologize for that, but Hope all is well. I'll probably do better on the next one. I'm finding some new things on this computer program, so maybe I'll add some music or something to it next time. All right. Have a good evening, guys.